Hello, in this video we're going to be using the normal distribution to approximate the binomial distribution. So it's not always applicable to use the normal distribution to approximate the binomial, but when n is a large value and the probability is close to 0.5, then the binomial distribution, which of course is discrete and would be a bar chart, looks very similar to the normal distribution, which is a continuous curve. So for a binomial, if x is given by a binomial distribution with n and p, and of course y will be our normal distribution with a mean of mu and standard deviation of sigma, then mu would equal np, because that's how you work out the mean for a binomial, and the variance would be that value np multiplied by 1 minus p. And as I've just pointed out, the normal distribution is continuous, but the binomial distribution is discrete, and as a result of that we need to do something called a half continuity correction. So as you should be aware, the probability of any individual value using normal distribution is 0, okay, which isn't that helpful if you're trying to compare it with a discrete distribution. But if you imagine each number, like say 56, actually exists between 55.5 and 56.5, so we need to imagine this sort of a cloud hovering around each number. Okay, so when we take our discrete values, which can only be whole numbers in some normal examples, we can sort of treat them as clouds of numbers. So our first question says, what is the probability that x is less than 84? We need to convert that into a normal distribution question using our half continuity correction. So we want all the values from 0 up to 83, but we don't want to include 84. So if we think about 84 as being a number with a cloud around it, which starts at 83.5 and finishes at 84.5, from a normal distribution point of view, we actually want to work out the probability of being less than 83.5. Whereas, if we want x to be less than or equal to 97, 97 has its little cloud between 96.5 and 97.5, but we want to include 97 in this question, so we actually are going below 97.5 to ensure that 97 is also included. And then one final example, if we want x to be greater than 95, again the cloud around 95 starts at 94.5 and ends at 95.5, but this time we don't want to include 95, so we're only going to start at 95.5 for our normal. So just to summarize, with the top left question, we don't want to include 84, so we want 83.5 or less. For the bottom left example, we don't want to include 95, so we start at 95.5 and go upwards. But for the top right, where we do want to include the 97, we go lower than 97.5 to ensure that 97 is also included. Okay, so let's apply this to an actual question. We've got x, which is binomially distributed with n equals 150 and p equals 0.6. And we've been asked to work out the probability that x is less than 84 and the probability that x is less than or equal to 97. So first of all, notice that n is a large number, 150 is large, p is fairly close to 0.5, 0.6 isn't far away. And once upon a time, before calculators did these things, it was impossible. Well, it would have taken a very, very long time to answer a question like this using the binomial distribution itself, because you'd actually have to apply the formula, 84 times in the case of the first question. Okay, whereas using the normal distribution as an approximation makes things a lot quicker. So firstly, we're going to work out the mean for our normal distribution, which is given by np, which is 150 times 0.6, which equals 90. And then we also need to work out the variance, which is given by np1 minus p. So you could start from scratch and do 150 times 0.6 times 0.4, or you can use the mean, which is np, and times that by 0.4, which is what I've done here, and that gives me 36 for the variance, and of course, therefore 6 for the standard deviation. Okay, so using my normal distribution notation, we're going to use a normal distribution for y with a mean of 90 and a variance of 36. Okay, so first thing to do is to apply this half continuity correction. So if I want x to be less than 84, that's the same as saying that I want y in our normal distribution to be less than 83.5. Using our normal distribution function, we want the lower value to be 0, the upper to be 83.5, the standard deviation to be 6, and the mean to be 90. And then sticking all that on a calculator gives us an answer, a probability of 0.1393. And then for x is less than or equal to 97, again we want y to be less than 97.5 because we want to include the 97. We can use the same lower of 0. Our upper is now 97.5. Our standard deviation and mean have not changed from 6 and 90, and we get a probability of 0.8944.